let's look at a couple of examples of problems that are specifically one-sided limits. That means that if you take a look at this one, for example, we are looking really for the limit as you are only approaching one side of the specified x value. In this case, we are trying to find the limit as you approach 1 from the left of this given expression. Now notice that you cannot simply substitute 1 in place of your x as we might try to do at first, especially in the denominator because we have a 0 down there. So what that tells us is that since we have 0 down in the denominator and we really cannot do anything to algebraically manipulate this, that tells us that our limit does not exist. So it's a matter then of figuring out if this function would approach either positive infinity or negative infinity. Now, a great way to do that is to simply graph it and look at what's happening as you approach 1 from the left, but we're going to try to tackle it algebraically. So we know this limit doesn't exist. And I'm just going to refer to it as f of x to make it easier to write. All right, and again, the reason we know that is because we have 0 in the denominator, which we know we cannot have, and there's really nothing we can do to algebraically manipulate this so as to simplify it a little bit more. So the way in which we figure out whether this is tending towards either positive infinity or negative infinity, we do a little side arithmetic. So we're approaching 1 from the left. So an easy way to do this is pick a number a little bit close to 1 on the left. Think again of it like a number line. So maybe 0.9, something like that. So what you're going to do, and this is where the little arithmetic comes in, we're going to substitute 0.9 in place of our x. And really, I don't care what the exact numbers are. Really, all I want to know is if this is coming out positive or negative. All right, so obviously up in the numerator I have a positive. And down in the denominator, that's going to be positive. So obviously positive over positive is positive. So what we say then is that this limit does not exist, but it approaches positive infinity. And if you're interested, go ahead and graph this expression on your calculator. Take a look at what's happening as you approach 1 from the left, and you should notice that that part of the graph just keeps going up and up and up. So let's try another one. So in this one, we are approaching 0 from the right. Now once again, you cannot substitute 0 in because we get 0 in the denominator. There's really nothing to do to algebraically manipulate it. So for this one, we do know the limit as we approach 0 from the right. And once again, I'm just going to call it f of x for convenience sake. Does not exist. Right? Again, that's because we would have 0 in the denominator, and there's really no way to algebraically manipulate it. So once again, we're going to do a little side arithmetic, but this time we're going to pick something just a little bit to the right of 0, so maybe 0.1. So we're going to do square root 3 plus 0.1 squared. And again, remember, I'm not really caring about what the exact numbers are. I just need to know if this is coming out positive or negative. And then in the denominator, I'd have 0.1. So obviously, this is going to yield a positive in the numerator, and we have a positive in 0.1 in the denominator, so that's a positive overall. So what we can say is that this approaches positive infinity. And once again, you could graph this on your calculator, take a look at what's happening on the graph as you approach 0 coming from the right side. And once again, you should notice that the graph just keeps going up and up and up.